Hi, Shruti. Welcome to the mock interview. Before we start, could you tell me a little bit about yourself?
Yeah, sure. Thanks, Martin. So, as you know, my name is Shruti and I'm a student right now in India. So, I'm in the final year of BTech and my branch is information technology. In the past, I worked as an intern with Uber, a software developer intern, and my like the technical languages that I am familiar with include C++, Java, Python, and Go. Mostly I'm proficient in C++ for the coding interviews, and I have a working knowledge of the other ones. And apart from that, I have worked on a few personal projects as well as team projects. And I also work quite actively with the tech communities around me. So yeah, that's about me.
Okay. So you mentioned your favorite or your preferred programming language is C++. On a scale from 0 to 10, what level do you think you are?
I think right now, I believe there must be a lot to C++ than I know. So I'll rate myself as 6 or 7. Like the part that I know, like that is sufficient for the interviews and all. But I think there must be a lot to C++ other than just problem solving. That's the part that we use for problem solving and all. So I can say around 6.5 or 7.
Okay. That sounds good. All right. So for this first problem, I'm gonna give you a list, and there's no tricks or anything. I just want to look for sorting this list. However, there's some constraints. Basically, the constraint is that we have a highest possible. The highest possible is 100. So that's something about this problem. I give you a list of numbers, and I already give you what would be the highest possible, and I would like you to sort this array for me.
Okay, so what is the use of highest possible? Like, what constraint does it define?
So yeah, I mean, so from the list that I'm giving you, which at this point is like the ones in line 4, but it could be more. The one thing that I can guarantee is that the highest possible would be 100. That's extra information for you.
Okay, so the highest possible number in this list is 100.
Yes.
Okay, and it might be present and might not be present.
Correct.
Okay.
Yeah. Yeah.
So I have to sort this list, and I am given a highest possible.
Yeah.
Okay. So, usually, in the simplest way, how I can we have a lot of sorting algorithms to sort any list. So right now, I'm not thinking about highest possible, but yeah. So we have a lot of sorting algorithms. Some work in order a quadratic time complexity, or some in n log n. So uh, I can sort this in up to n log n time complexity, where n is the length of the input. But if I'm given the highest possible,
right,
how can I make use of that?
Correct.
So, the final list that I need to get is 37, 41, 53, 65, 89, and 91.
And I'm sorry, it would be in descending order. So basically the opposite of that. Yeah.
Okay, okay, descending order. Okay. 53, 21, and 47. Okay, so I want the largest element first. So the largest element is actually either this highest possible itself, if it is present in the array, or the just like the immediate smaller one. So if I try to pick these elements one by one, so if I'm at 37, I know this is less than highest. So is the like input always valid? Like, can it have elements greater than 100 also, which I might have to discard or something?
No, input is, yeah, it's valid. Yeah.
Okay, okay. So that means any element and counter will always be less than highest possible, less than equal to it. So, so basically, as I said, like I can do this problem in n log and time complexity. So, like, do you think I should try to do it better?
So you're saying you can just sort it with n log n, right? Is that what
Yeah,
you're saying?
like through more sort of quick sorting algorithms.
So is there anything we can do using the highest possible? We already know the highest possible is 100. Is there a way
Yeah.
to do this in a better time complexity?
Okay. Yeah. I should think about that.
Okay.
Mm, mm, highest possible. So when I'm at 37, I know I'm smaller than highest possible. So basically, I want the immediate smaller. So that will be my first element. So if I'm traversing my like so like say I'm searching for the element of at the first position, which should be 91.
Uh-huh.
And let's say it's required. I name it as um, the required element that I'm searching. So I see 37. So initially I give it 37 value. Then I see I have something greater than it, and then I can update this to 89. Now 41 it is smaller than this, so no update needed. Then 65 and 91. It's again greater than it. So in that way I can find 91. Like this can be a simple algorithm to do that, but I'm not really making use of highest possible here. How can I do that? Hmm. There can be many ways. So this actually what I'm saying right now, this will actually become a quadratic time complexity algorithm.
Mhm.
I can use something like a heap as well to like max heap. But in any of them, I'm not needing the highest possible or making use of it.
So
Mm,
maybe let's think about it. Oh, sorry. Uh, Maybe let's think about it this way. Yeah, using the highest possible, is there any way we can use like a data structure and then, yeah, because right now, let's say memory is not a concern. So we maybe are making a little bit of trade-off for, because we do want a better time complexity than n log n. And let's say for now, the memory is not an issue. is there any data, like any way we can use a data structure and the highest possible to make the sorting?
Okay. A data structure that can help. Basically, what all data structures do we have? Like we have stacks, queues, we have heaps. So I'm thinking a heap can be used here. I'm giving them, yeah, sorry.
Yeah, how about another array? Could you use just another simple array?
Okay. Simple array. Um, simple array. Okay, so basically I want it in descending order. Let's say I have a separate new array. I initially have 37, then I find 89. Since it is greater, I can put this before 80, before 37. Okay, so I want for descending array. So initially at the highest possible. So now I have 37. I push it at the back. Now I have 89, which is less than 100 and greater than 37. So should be placed here. Like say I find the correct position for it, like similar to what we do in an insertion sort, like we can just find the correct position for it by traversing from one of the sides. Then if I have 41, then yeah, I can do that to find the descending order array, but that is not an efficient way to do this. It will be again quadratic time complexity, and I'm not making really a use of highest possible.
So how about this? What if we just use the an array, and what can we do something with? Let's say we know that the maximum is 100. So we know that if we have an array, there would be a lot of numbers here, and then 100, right? So we do have this information, and then we also have the original array. We have this original array. So actually this will be much larger, but no, do it like this. So let's just take a step back here. We use the original array, and then we can play with this idea of having the extra array with 100 slots, because we already know that it cannot go further than this. Is there anything we can do with this information?
Okay. I have this array, some elements, and 100 highest possible. And this is what I have to sort. So you're saying if I can make use of this. Mm, okay.
So maybe why don't we start placing the real values in the second array? Like, let's say, let's start with this one. So before 100, there would be several here, a bunch, but the 91 would be here. So let's maybe do the other one, 89. Would be like that. So is this helpful? Well, actually, this is the index, so I guess the correct way of saying this is like this. Yeah, so we know this is the indexes in line 13, and then we can start filling the gaps, and maybe we can come up with some idea from doing that.
Okay, so you mean like I'm just asking a little about the hint. So like is this array something like 1 to highest possible? So you're saying this one is index and these are the elements, is it?
Yeah, which right
Like
now it's all 0. Yeah.
mm-hmm.
And actually, yeah, I mean, this is 0 and this, but here is 1 and here is 1. So
Yeah. Okay. So I have a highest possible. Like, is there some range for highest possible? Like, if we can actually have an array with with element 0 to like the size of it can be highest possible.
so the values from the input array, could
Yeah.
be 0 to 100, only 0 to 100. That's it. No negatives.
Okay.
Yeah.
Okay. So let's say we have an array of the size highest possible, like +1. So we have elements with index 0, 1, 2 up to 100. So initially that new array is empty, and now I have 37.
Mm-hmm.
So let's say I put a 1 at index 37, then I have 89, then I have 41. So like I can correspondingly like mark those indexes in the new array. And yeah, so and then I can actually like make another array and basically traverse this array. So this array, like say, this is the temporary array that we are using right now. So
Right.
to create, to basically mark presence of the elements in the original array. And then once we have it, we can like iterate over this array from the beginning till last, and we will like obviously be traversing the elements in an increasing order since the elements are the indexes itself. So then we can get that will give us an ascending order array. Otherwise, since we want like a sorted array in descending order, we can traverse this array in the reverse direction and get the elements in the required order. Yes, that would be. So just one thing is here, like what is the possible range of this value, highest possible? Like, because we'll be using memory of that order.
So you're saying what is the highest possible range of the highest possible?
Yeah.
No, it's
Basically, the better question would be what's the range of elements in the array?
0 to 100.
Okay, for this particular case, yeah. Okay, fine. So what I'm thinking is I can do this in order of like a space of the order of the highest possible value.
Mhm.
So a time of and the time complexity would be of the same order.
What's the order of time complexity again?
So first, what I'm actually doing is I'm traversing over this array and
Mhm.
marking the presence of each element. So that can be done in O of n, like
Uh-huh.
the number of elements in the array.
Mhm.
So that is O of n. Plus, I'll be traversing this array in like in the reverse, in the backwards direction. So that gives me a time complexity. Like I'll be doing the work of the size of this array. So
Mhm.
let's say the highest possible is h. So order of n plus h.
Yeah. And in this particular case, h is 100 and it's a constant, so you could drop the h. But yeah, I like what you're thinking. Yeah, I think you're in good track.
Yeah, so that is the current solution, and the time complexity is in order of h, but if we say that's a constant, then yeah, we can say that's one also. So do you think I can do like, should I code this or try to do better?
Yeah. Could you maybe, yeah, you feel ready to code this? What you describe is a good approach, so I think it's good that maybe we go with this and start coding.
Yeah. So I create a function for this. So I don't actually need a new array. I can modify the original one as well if it works. Can I modify the original array into the sorted order?
Um, yeah, we can.
Okay, and I am given the highest possible. So I can create an array of size of highest possible. So let's call that an auxiliary array. So highest possible plus 1. And initially everything is 0. I have not seen any element. Now I can traverse over my initial array.
Hey, Shruti, just really quick before,
Yeah.
I think maybe you can move your microphone a little bit closer. It's a little bit, just sound a little bit far.
Okay, is this better now?
Yeah, thank you.
Okay, yeah. So this the size of my array. I traverse the array and mark the presence of each element. So uh, maybe and use the element in the array as an index. So mark it as 1. Now I have marked all of them, so I can just traverse over this auxiliary array. Which will be I greater than equal to 0. Since the numbers are non-negative, so we can do this. So therefore, like we have just indexed the element, use the elements as the index in this auxiliary array. If they are non-negative, and now I can travel through this array and see what all elements have I seen, and I'll be seeing them in the descending order. Then I can, whenever I see an element mark, that means I have like I had that element in the original array. So now I can just overwrite in the original array, and I get the descending order. So I can just do, let's have an index k which is equal to n minus 1. So if auxiliary I is 1, so what I can do is the array, the kth element in array is equal to I, and just decrease both of them, or I will anyways get decreased here. Yes, so whenever an element is marked, I put it in the original array and like decrease the pointer to the left, and my I will be reduced similarly. And yeah, so my original array will be modified. Maybe I can test it over this the input you gave me. So I have this. So I mark the presence of each of these elements in an array of size 100. Since I cannot draw that much big array, so let's say initially everything was 0 till 100th position. So 0 at 1 and then till 100th position. Then I traverse this array from the back, and first I'll find at index 91. I'll find that value to be 1. And this auxiliary array, let's say it was here. So I find a 1. So I will put that element. Okay, so I actually want a decreasing order. So I'll put it in the front rather than back. So I'll put it in the front of array and one step forward. And if like initially I'll find zeros, so I'll just keep moving forward. Like I'll keep moving to find new values in the backward direction like this. And as soon as I find this one, I'll put it in the front and move forward in the original array as well. And move this pointer one step ahead till I find one. Yeah, this will go.
Okay. Do you feel confident with this algorithm so we can start doing some testing, or you want to do another dry run?
No, I can test it now.
Oh, yeah. Could you just write a few tests that you think are worth testing?
Yeah, actually, I'm trying to look how to test here. I have an option of run. Okay, where can I give the input?
Yeah, you can use the main, and then if you just click run.
Okay, okay.
Yeah.
Okay, so like I can give the input within this main itself. Fine. Yeah, that works. So let's see. Let's first check for this as well. So 37, 89, 41, 65, 91, and 53. Let's try sort. So social vector in science line. Recipe council. 91, 89, 65, 53, 37. Yeah. So one thing is let's check it. One case that I want to check is on check this on as a sorted array as well. So let's say it was already a sorted array. So yeah. Yeah, so it works. Uh, let's say this was an empty array like um, yeah. Um, there's nothing actually different in that case. Yeah, so just nothing got printed. So some other edge case that I might want to try. Yeah, I think this will work. I checked it on these cases as well. This will work.
So, is there any other test that you think will catch some edge cases?
Okay. One thing is like when we have the highest possible in the array itself. So like minus, like let's just say 10, 35, 100, 91, 28, something like that. And I print that. Yes, this works. In each case that I should check. So yes, if the input is valid, this will always work. This will always work.
How about duplicate?
Okay, yeah. So I actually wanted to ask that in the beginning. I just forgot that. Yeah, that's right.
Do you think it will work for duplicates?
But duplicates basically instead of for duplicates, I can store a frequency of the element, and whenever I find an element, whenever I find an index in auxiliary array which is marked, which is non-zero basically, so then I can put that element that many times in the original array. So yeah, that needs to be worked on. So let me actually include that. So if it is non-zero, then this this will basically now show the frequency for that element. And now instead of just writing it once, I'll have to write it the number of times it is present. So for an count is equal to 0, count less than equal to auxiliary I, plus. So I will write it. So the element is I itself, the index. So yeah, so the frequency will be the element or like element at the get index, and yes, I write that element in my original array that way. Now it will work for the duplicate. So let's try now as well. So let's say it was 35 and this is 28, 28 and this is 6. Yes, so this would work for duplicates now.
Okay. I think we're in a good spot to move to a different problem. So maybe yeah, I'm gonna scroll down, or yeah, I'm gonna scroll down. So this one is that for a given input, for a given array, um, you will have to do the multiplication of all the other numbers except that index. So this array will return this one. So 7 times 3 times 4, that's 84.
Okay.
And then 1 times 3 times 4 is 12, and so on and on. Yeah, so that's the,
Yeah, I get it. So basically, the answer for that particular index is product of all the elements except itself.
yes, yeah.
Okay. So I can store the products, like I can build a prefix array and a suffix array of the products. So basically, a prefix array will be 1, then 1 into 7, 7, then 1 into 7 into 3. So basically just 7 into 3 now. So 21, now 21 into 4, which is 84. And similarly, I can have a suffix array. So I'll build the suffix array from backwards. It will be 4, then it will be 12, then it will be 784, and now it will be 1. So if I have these suffix and prefix arrays with me, so standing at any index, my answer will be like the answer I will be prefix of I minus 1 if it exists into, otherwise it will be 1. So prefix of I minus 1 into the suffix of I plus 1. Yes, so basically at 1, the left part doesn't exist. It will be 1 into the suffix. Okay, no mistake, this is 84. So, and the suffix will give 84, which is this one. So, answer at 0th index will be, uh, it will be 84. Then I am at index 1. So the answer will be prefix till this part. So basically it will be 1 and suffix ahead of it, which is 12. So answer will be 12. Similarly, when I am at element 3, my answer will be prefix, which is 7, into suffix, which is 4. So it will be 28. And here my answer will be at when I'm at element 4, prefix into suffix. So prefix is 21 and suffix will be 1. So that is like the boundary case. So it will be 21. Yeah, so I can just have two suffix and prefix arrays of products. Does that
Okay.
help?
Yeah, I think I can proceed with the code.
So shall I code this?
Yes, yeah.
Okay. And just for completeness, the time complexity will be order of n, like n is the size of the input, and space complexity will also be order of n since I'm using prefix and suffix to store these values. Yeah. So what I have to return is this new array, right? This.
Yeah,
So
966.
vector, right? I just need to build two supporting arrays. So vector and prefix same size. So in one suffix or in one prefix order. So when I'm trying prefix array, so value type index in this will be, so I can just start from index 1 and not really. So like what I can do is just put the first element as it is. So product 0 is as 0 itself. I could have handled that in the loop also, like any way it works. So then prefix at ith index will be prefix at I minus 1 into the current element, that is at I. Similarly, I can build the suffix array. Just suffix product. I'll build it from the back. So the first element is the original element itself at that index, and then I'll traverse it from the backwards. Yeah, so n minus 2 I greater than equal to 0 minus suffix product I will be suffix I plus 1 into the element at this. So now I can build my final answer. Vector int so my answer at ith indexes prefix product at I minus 1 into suffix product at I plus 1, but given that they exist, so let's just put a condition here. So if I is greater than 0, then this, otherwise 1. Similarly, if I is greater than 0, then this, not really actually 0. So if I is less than n minus 1, then it will be the suffix product till next index, otherwise it will be yes. So then I can just return answer. Yeah. So I'll run it over the like this test case. So 1734. Yeah. So So I have my input array, I have a prefix and suffix array, and I will build them. So I start from the starting, and my array in here, the first element will be the 0th element itself, 1. Then the next elements will be the product till the last index into that, into myself. So that means 1 into 7. So now at this 7 into 3. And then again myself and the previous product. So that is 4 into 21, so 84. So the prefix array is created. Now in the suffix array, my last element is the same as the last element originally. So that is 4. Then second last element will be product till the next index plus this element itself. So 3 into 4, which is 12. Then 7 into 12, which will be 84. And then 84 into 1, which will be 84. So I will have the suffix and prefix arrays created. I start from n by n minus 2 since I put this, and yeah. Then I can build the answer. Answer will be created like from the at 0th index prefix product I minus 1. Since but I is not greater than 0, so it will rather take 1. So 1 into I is less than n minus 1, so it will take prefix product of I plus 1. So prefix product at index 1 into 1, which will be 84. Then at index 1, it will be greater than 0. I is greater than 0, so prefix product at index 0, which is 1 into next index suffix product, which is 84. No, not 84, sorry, 12. So since it is 1, it will take for index 2. So it will be 12. And at index 2, it will I greater than 0, so it will take, I'm at index 2, it will take 84. Sorry, previous one. So it will take 7. And the next in suffix, so it will 4, so 28. And in the last element, it will take the previous prefix, so it is 21, into the next suffix, which is 1 because I am equal to n minus 1. So 1 will be the suffix taken. So it will be 21. Yeah, this will work. And I have not actually handled the empty case here. So that can be vector. Otherwise, it will give an error because I'm indexing the first element. So if n is 0, I just return empty vector, yeah. And any other case, in this case, like there's no problem with duplicates and all, since I'm taking products and yeah, like they won't cause a problem. And yes, this should work.
Do you think maybe like write a few test cases, or maybe run the one you just the original?
Yes,
Just yep.
yes. Uh, One thing I'm thinking right now is about negative elements.
Maybe for now assume that there's no negative elements.
Okay, okay. And even if there are, they won't cause any problem. But yeah, okay. So if there are not any negative elements, fine. So you're asking me to run it, right? On some test, to
Yeah.
check it. Yeah. Okay. So the functions. And this. This is the same array, and give me a vector.
maybe.
Okay, this is strange. So the error is product. Okay, yeah, so the function is defined later. It should be before the name. So mm, okay, so one thing I like is very big because the values are very big. Let's take smaller ones. The same as we were running ones, so 1734, 1734. So we have 84, 12, 28, 84, 12, 28, 1. Yeah, so that is what we, that's the correct answer also. So let's run it. Let's have a zero value as well. It will actually be zero. It should be zero for all your values. Okay.
Is
So when it is, yeah, sorry.
this, yeah, this is correct. How about 2 zeros?
Yeah, then everything should be zero. Yeah.
Okay.
You told everything is positive, like no negative, so yeah, this would work.
Okay. I think we're in a good spot for stopping.
Yeah, yeah,
So we're gonna move now to the feedback part of the mock interview.
yeah.
So the first step is asking you how do you feel you did? Like how do you feel you did in this interview?
Actually, I didn't do good for the first question. I couldn't come up with an approach in myself. I took a lot of hints. So yeah, that was something I could have done better. I just couldn't think of that approach. The second question, I think I was able to think it. So yeah, I think it was just all right. Like not a good one, definitely.
Okay. So I guess we're gonna move on to my feedback. Actually, I think it was a good interview. The first problem, it's a tricky one because yes, you have to see that pattern. But once with once we start with some of the hints, you were able to figure out. And the there are several aspects of the interview. Once one is coming up with the algorithm, but the coding part that was flawless. That was very good. Um, my only comment is naming, for example, line 36, ox and array. That could improve a little bit. That's a nitpicky thing. No, not so much, but yeah, the algorithm works. Another part is I wish you would have, first of all, for this, particularly for the first problem, solve the problem and ask for clarifications. I think that's true for both. Ask more questions, more, requirements, more like, is it negative? Is it overflow? Is it, what are the valid values? I think some of these scenarios you find out during testing, and I think that's a little bit of a negative mark during an interview. So yeah, I would ask more questions up front, and I will try to really solve the problem in the dry run. Before you even start any line of code, make sure you have it, the problem solved. So I think that's for that part. I think overall it was very good. The I wish when you were, and this is a hard thing to do, but when you were coding, it was a little bit quiet, and it felt like you were talking to yourself, but not so much explain your thought process. So I would do that. I would try to think out loud, but also, yeah, think and kind of like make the interviewer, know that he's like part of this and kind of like engage explain your thought process more, I would say, overall.
Yeah.
So, and the last bit I would like to see is, you did do it in the second problem, the validation, but I think particularly the first one could have used some minor validation optimizations, like what if the array is empty? What if, there's only one, and what about overflows? Those are also all great questions to ask during an interview. And I think that would have made this like that just gives you points. I don't know. So yeah, overall, that's my feedback. Now we're actually gonna open it for the people who attendees. So just a reminder, this is actually feedback for both the interviewer and the interviewee. So whoever wants to share their feedback to either me or her, yeah, please raise hand or just unmute yourself and feel free to share any feedback.
I have a couple things to share.
Okay, thank you.
For the candidate, I think there is scope of improvement in the requirements clarification and testing areas. Those are, I think, the two major areas I would focus on if I was in the candidate's place. So I'm sure most people on the call would have noticed. I did see some discussions as well. So for requirements, we want to make sure we are asking questions enough to understand exactly like what the problem is. So for the first one, the sorting one, like I think it wasn't clear. It was clear that what is the highest L value that could exist, but the range wasn't clear. Like, so it was something to do with range and the candidate wasn't able to catch it. So some questions could be like, could the array have like, let's say negative numbers, or what would be the minimum value? I know there was clarification later, like that what would be the range of elements, but that was like 20 minutes into the interview. So I think that was too late. Other than that, I think like there were other areas, like even for this problem, the product problem, like it's important to know like what is the range of elements, because if there are larger elements, then I mean a return of vector int won't actually work. It could be vector long or vector long, or even that might not work. So it's important to have that discussion about like the range of elements. Like, so in general, like one way to actually remember this is to, whenever you see an array of numbers, always ask questions. Those questions could be about, are the numbers integers or floating points? What would be the range of those numbers? Does it include negative numbers? Does it include zeros? Like, it's important to understand. For some problems, you may not need to ask, does it have zero or negative numbers? It may be obvious. But if you have that checklist in mind, it actually helps a lot, because anytime you see an array of numbers, you have to ask a clarifying question to understand what kind of number they are. They could be real numbers, they could be imaginary numbers, complex numbers. Like, so it's important to ask question, at least understand like if it's floating point, integer, negative, or what sort of number is it. And then so that's for the requirements clarification part. So I think the first question, there could be other problem specific requirements, like if you're sorting something, then depending on the approach, you might want to ask if it has duplicates or not, because that might affect your algorithmic approach that you come up with. So that's the first part. Then comes problem solving. For the first one, I know that the approach wasn't something the candidate was familiar with, so that's fine. But overall, I think for this, at least for the second problem, the problem solving approach was good. The candidate was very quick in solving, like basically writing the code for the approach that they had in mind. So that was good to see, like the changes, like the code, all the loop conditions, the end conditions, they were being, it was pretty good. She came up very quickly with those conditions, and there were very minimal errors in the initial code. And so yeah, I would say problem solving approach was good. I felt for the second problem, the candidate was already familiar with the problem. So that might be the reason it actually like struck up really quick, but then still it gives me some data points like as to like how the candidate would approach problems like this. For the coding aspect, I think naming wise, I'm not worried, but maybe n, like single variable names I would avoid, like something like n. I would just use count or size, something like that. And then I would avoid ternary operators in code, line 63. And there's a lot of code in line 63. Like it's very hard to understand, debug for any other developer. So I would avoid anything like that in production code and in the interviews as well. So that's for the like coding aspect. And the other thing I mentioned, like testing is another area which needs improvement. Like, if I'm writing the code, I would test it alongside, like I would follow it through, like not just click on run and then see that, oh, the numbers displayed are weird. I would just follow it or the code doesn't compile. I mean, I would try my best to actually test it before, like a quick look through the code should help. But yeah, I want to test other cases as well, not just the cases that the interviewer already shared. Just because the code works for that specific test case doesn't mean your code will work for all other cases. So I would test edge cases, and edge cases have to be thought out explicitly, or at least you have to, like I would explicitly state that, okay, well, what about small cases? Like I'll think of those, like what if it's an empty array? What if there's just one element, or they're just two elements? Like for this product problem, I would have two elements as well, one element and zero elements. And then, yeah, I think the cases with zeros were good. Even for the first problem, yeah, I'll come up without hints. I would try to come up with edge cases. So that's the testing part. But yeah, other things pretty much covered by Martin. For the interviewer, I think the second problem, it was good. The candidate was able to catch it. So there weren't much hints needed. For the first problem, I did notice that, like, just to make sure that the interview actually proceeds on track, like the actual approach had to be discussed. So I would generally avoid anything like that if I'm in an interview. It's okay if the candidate doesn't get it. But in this specific case, I noticed that it actually helped, like sharing the optimal solution actually helped test like the implementation. Like the candidate was actually able to implement counting sort, like without being familiar with it before. So I think that actually helped. But in general, I would like, it's not ideal to share the solution. In this case, it helped, but in general, I would maybe give other hints, like some hints that I could think of. Maybe they're not perfect, but it's just some ideas that I had were like, I would ask the candidate, like, is it possible to like sort the array in less than n log n complexity? So, basically, I want the candidate to think like about algorithms other than comparison sort algorithms. So all the comparison sorting algorithms would take n log n, but there are other algorithms which are more optimal. So I would try to figure out, is the candidate familiar with them? If not, then yeah, I'll suggest other hints, like something like I would ask about the algorithms, the sorting algorithms that the candidate is familiar with. So if they give me that, hey, heap sort is like O of n log n, and there's the space complexity is constant, then I would ask them, like, can you do a time space trade-off and see if you can optimize the time by trading it with space, and see if the candidate can actually come up with it. If that doesn't work, I would just simplify the problem. I wouldn't ask them to sort an entire array of like some particular range. I would just tell them, hey, the array has just 3 distinct values. How are you going to sort the array? If the candidate is able to think of the count approach, in most cases they should be able to, but I'll see like how quickly they catch that. And then they'll just do it using count. So I'll ask them, like, what if there are 5 distinct values? Are they able to come up with the array approach, or did they still use the count approach? And then I'll generalize it. What if there are 100 units distinct values? Some candidates might come up with using a hash table, like depending on this requirement. Some might not immediately go towards the array way, but that's fine. It helps me know the thought process of the candidate. So yeah, those are just some of the hints. I would generally avoid like just sharing the optimal solution that I have in mind. I mean, because the candidate is going to think, hey, the interviewer had a very specific solution in mind, and until I had that, the interviewer wasn't happy. I mean, I would just refrain from that. But yeah, there could be different ways to solve the problem, like simplify the problem. And usually if you have a fixed question that you ask multiple candidates, you would have some simplifications. So for a new question that is picked up, I can see like that it's not easy to come up with those simplifications. But there's a way usually for each problem that the interviewer picks up. A good problem would usually have simplified versions as well as more complex versions, so they can adapt during the interview. So yeah, those were just a couple of thoughts I had.
Yeah, actually, thanks a lot. I'll keep those in mind. Like, they're very helpful. Thank you.
Yes, thank you. That was very thorough feedback, and it's great. Yeah, thanks for sharing that. Does anybody else want to share feedback for either the interviewer or the interviewee?
Yeah, I don't have any such feedback, but I think Abhilash actually summed up everything, as well as Martin and Shruti. I would say you both did a good job. So it was really good observing both of you. So I think Abhilash has covered everything. So that's good.
Oh, thank you.
Yeah, I will also like to
Can
add.
I share one more point?
Yeah, absolutely.
So I thought that in the second problem, she should have explained the brute force approach first, or other approaches, before directly going into this approach. That's it.
Okay.
Yep. So, hey, this is Roger. Actually, I'm attending this for the first time. I joined when it was already almost first question was about to be finished. So I don't know about the first problem, but definitely around the second problem and whatever Abhilash was saying, I do agree with most of it. However, also like, like, I don't know about the candidate. Is it her first interview or something? She may be a little bit nervous and all. Because when I looked at the first problem, it took her at least half an hour, and that was her first solution based on the conversation we were having. So she was pretty late with that. So I'm just thinking from her point of view, she tried to get the second solution as soon as possible. And I maybe she knew this problem already. Like, that is my gut feel. Maybe not, but it was not very clear. But yeah, definitely you should have, once you know the problem, to maximize it to your advantage, still clarify requirement. If you would have done that part, it would have been amazing. Your second I just saw the second part of the interview. That would have been amazing, because you don't have to even handle all these cases, whether the numbers are long or not, most likely not. But just by asking about it, you are showing that, hey, it's a free point for you, that you do care about it. And because in 45 minutes of interview, nobody is going to ask you, what if you have to implement a big integer? Nobody is going to ask you, unless you are going for a senior role or anything. So that's pretty good. So I really liked it. And Martin, you give her actually good hints also, based on what I saw on the chat thread for the first problem. But yeah, other than that, Abhilash has said everything. I think yeah, just work on it, and it was a pretty good interview. I liked it. I would have given a good feedback based on the second problem, by the way.
Yeah, thank you. Actually, yeah, that's right. I support, like, did not ask a lot of clarification questions. Actually, that is also because in the past I had given some interview, and it like just happened that I couldn't actually code things and just ask a lot of clarification questions. So I think I just got a little opposite of it and asked like very minimal ones. So yeah, but I'll try to make a balance, like at least ask the necessary clarification questions. That is right. Like, especially in the second question, the long thing was very important. Yeah, so thank you.
And I agree also with the feedback. I think Roger and Abhilash, and I think they said about me. Yeah, for the first problem, I was a little bit, I was trying to keep the flow of the interview going, and I kind of didn't want it to be in a kind of like going to a kind of like bad state. But you guys are right. I think a better approach, instead of kind of giving the solution and just, well, not giving the solution, giving basically the data structure of the solution, a better way would have been just, simplify the problem, making it a little bit smaller. And I think that's great feedback. I will try to implement that or not. Okay. Does anybody have anything else to say?
Just curious, like was the candidate familiar with the second problem?
Yeah, so that wasn't something new. Like, yeah, I had done this sometime in the past. Yeah, that's right.
Yeah. So for problems like these, like it's usually very clear, like whether the candidate has solved a problem or not. So in these cases, you would notice that like you receive there's less weightage that is given on the actual solution, because I could figure out that I mean, the candidate has looked at it before, even just from the naming, the way you actually named, like prefix and suffix. So and that's fine. It's fine if the interviewer knows about it. But in those cases, the more important things are like again, requirements clarification, like getting deep understanding of the problem, like what kind of numbers are there, what kind of input is it, because like I've seen this is a common pattern. Like any problem that the candidate has already solved before, they would quickly jump into the solution because they know, hey, I'm confident, I know how to solve it, so I don't have to worry too much about thinking of better solution. So they directly jump into the problem and they ignore the things that matter, like understanding the input. What if my input was slightly different from the lead code question?
Yeah,
So
that's right.
so if for questions that you are already familiar with, maybe just an extra check, a mental check, that you still have to make sure that it is the exact problem that you have solved, and to like just validate those requirements, because interviewer is not like they're gonna know for sure, and they'll only judge you on the things, they'll only evaluate you on the things that are other than the problem. So I'm like, for this one, like I would look at other aspects, not the actual implementation. I would look at your actual, how you've implemented and what were the inputs and how did you validate it. But yeah, that's just another thing to think of for problems you've already solved.
Yeah, that's right. I'll keep that in mind. Thanks.
Does anybody else have thoughts, feedback with the interview? Okay, I'm gonna start the recording now.